All right, so we're jumping into section 9.3. And we're going to solve quadratic equations. So we've been talking about how we graph quadratic functions, some properties of quadratic functions the last few days. Today we want to solve equations. So our equations, our quadratic equation, ax squared plus bx plus c equals 0. This is what we call a quadratic equation. So instead of y equals or f of x, we have this thing equal to 0. And when our equation is written like this, we say it is in standard form. And what we're interested in today is when we have this equation, we want to find x. Well, when we solve this equation, we can have 1, 2, or no solution for a quadratic equation. And we're going to solve, today we're going to solve this quadratic equation. We're going to solve it in two different ways. We're going to graph the quadratic equation to graph the related function to solve the equation, and we're going to talk about solving by taking square roots. So our solutions are the x-intercepts of the graph. So when we graph our quadratic function, we're looking for the x-intercepts. And remember, the x-intercepts is where it crosses the x-axis. That's what we mean by x-intercept. Yes?
Is this going to be like only solving by like looking at a graph and seeing where it crosses?
That's going to be one of the ways that we do it. We'll look.
Okay.
Yeah, and we'll talk about another way. We also call the solutions roots or zeros of the function. So if a problem says find the roots, find the zeros, it means the same thing as solve. So just different ways of saying the same thing. So did I tell you that I used to have plants in here? You can see the hooks on the ceiling. I used to have plants. Yeah. What happened was the reason I had to get rid of them is they had no roots. No roots. No roots. All right, so let's talk about the first way we're going to solve these equations is solving by graphing. Today we're going to talk about solving by graphing and solving by taking square roots. And then next week, what we'll do right before spring break, before we have Pi Day next Friday, we will talk about solving by factoring. So the factoring we did in Chapter 8 will come back next week. So I want to go through a couple of examples. So we want to solve by graphing. X squared minus 4 equals 0. That's our quadratic equation. So because when we solve by graphing, we're looking for where it crosses the x-axis. So we need to be more accurate with our graph than just kind of approximating where it goes. So in general, when we solve by graphing, we need to make a table of values to get an accurate graph. So I'm going to make a table of values for this, x, and then we'll have x squared minus 4. That's how we're going to get y and y. And we'll do our standard -2, -1, 0, 1, 2. And I'll do my graph over here. So when I plug in -2, -2 squared is +4, minus 4, I get a 0. So I get a point on my graph right here. So that's one of our solutions. Our graph crosses the x-axis right there. We plug in -1. -1 squared minus 4 is 1 minus 4 is -3. So I get a point down here. Oops, one more. When I plug in 0, 0 squared minus 4 is -4. So there's my vertex down here. And then I know because it's symmetrical about the vertex, this is going to be -3 and 0. So my graph looks like this. And my solutions are x equals -2 and x equals 2. And those are my two solutions. So this quadratic equation has two solutions, x equals -2 and x equals +2. Yes?
If, like, as we said, we already found the x-intercept early on, could we stop there and just have one solution, or do we have to have both solutions?
You have to have both solutions.
Okay.
If it has two solutions, you want to list both.
Okay.
So if you stopped, I would probably give you 3 out of 4 points because you missed the other solution. All right, so this quadratic function, quadratic equation, has two solutions, x equals -2 and x equals +2. And a lot of times we'll write that our solution is x equals plus or minus 2. All right, let's look at another one. X squared minus 4x plus 4. So here we're going to start our graph by doing the stuff we've talked about the last couple of days. This is A, this is B, this is C. Negative B over 2A is going to be the x-coordinate of my vertex. So negative B over 2A is -4 over 2, which is 2. So that's the x-coordinate of my vertex. I plug that in. Y equals 2 squared minus 4 times 2 plus 4, which is 4 minus 8 plus 4, which is 0. So my vertex, this is nice. My vertex is at 2, 0. So this is a nice one because my vertex is right here. Does this parabola open up or down? Up. So if I go up from here with my parabola, can it cross the x-axis anywhere else? No. So this is my only solution. My solution is x equals 2. That's the only one. It can't, if it's going up from there, it can't cross the x-axis again. So for this one, if you get that one solution and that's the vertex, you don't have to keep going because you found the only one. Now if the vertex is not on the x-axis, then you're going to get, you could get two solutions. So then you'd have to keep graphing your points. So that one turned out pretty nice. Because this one looks like a messier equation than the first one. But the solution, we only end up with one solution. So we had to do not very much work on the graphing. Let's look at another one. X squared plus 5 equals 0. Well, let me do this. This is A. What is B? B is 0, and that's C. So negative B over 2A is negative 0 over 2, which is 0. And the y-intercept is 5. And actually, what I'm going to do is plug this in. Y equals 0 squared plus 5, which is 5. So the vertex is at 0, 5. So my vertex is up here. Which direction does this parabola open, up or down? This is positive, so it opens up. So my parabola is going to look like that. Can it ever cross the x-axis? No. So this has no solution. For all of these, the domain would be all real numbers. And for this one, the range would be y is greater than or equal to 5. This one, the range would be y greater than or equal to 0. And if I go back here, the domain would be y is greater than or equal to negative 4. So this one can never cross the x-axis, so we get no solution. So once we found our vertex and we knew it opened up, we found no solution. If this one were negative x squared plus 5, then it would open down, and we'd have to graph some more points to find where it crosses the x-axis. All right, so questions on our graphing? Yes? Because it doesn't cross the x-axis. Our solution for this kind of equation is where it crosses the x-axis. Now, in reality, graphing is not the best method for solving quadratic equations. There are other ways that are better for solving quadratic equations. And one of those better ways is using square roots. And when we can solve this way, this is really the best way to solve when we can do it. So we use square roots when b equals 0. So for example, we have 5x squared minus 45 equals 0. I don't really want to have to graph this function because my y-intercept is at negative 45. So that's way, my graph would have to be really, really big to graph this thing. But because I have only an x squared and a number, I only have the a, x squared, and the c, I can solve using square roots. So what I want to do, I'll write my steps over here. We want to get x squared by itself. And to get x squared by itself, we do what we've done in the past for solving equations. We're going to add something to both sides. We're going to divide both sides by something. We're going to get x squared by itself. Once we get x squared by itself, we take the square root of both sides. And when we solve by taking square roots, we always get a positive and negative answer. I'm going to say one other thing. If what's under the square root I'm just going to use a symbol, square root, is negative, that means we have no solution. So in your calculator, if you try to take the square root of a negative number, your calculator is going to give you an error. That's your calculator telling you there's no solution. So these are our steps. Get x squared by itself, take the square root of both sides, and we always get a positive and negative answer. So let's do that. I'm going to add 45 to both sides. And when I do that, I get 5x squared, these go away, equals 45. Divide by 5. And I get x squared equals 45 divided by 5 is 9. Then I take the square root of both sides. Square root of x squared, the square root undoes the square. So the square root of x squared is just x equals, and the square root of 9 is 3, but I get a positive or negative 3. Because positive 3 squared is 9, and negative 3 squared, negative 3 times negative 3, is positive 9.
And it's okay to have that negative. If it's on the outside, you're taking the square root. It has nothing to do with it being under the square root.
The number under the square root is where we have to deal with this. After we take the square root, it's fine to have a negative.
And if you haven't written those 4 or 5 steps down from the right, you need to do that because those are very important.
This is how we solve by taking square roots. So if we can do this, this is usually an easier way to solve a quadratic equation. So let me go back here. How about this one? We could have just added 4 to both sides and got x squared equals 4. And we take the square root. The square root of 4 is 2. And we get plus or minus 2. Isn't that easier than making this table of values? Yeah. So if you can solve by using square roots, it's usually easier. Yes?
And this only works if b is 0.
Only if we don't have that x part in there, yes. Because that x kind of messes, then we have to do other stuff. And we'll learn a couple of other things that we do when we have that x in there.
Did we give that a special name in our last chapter of factoring or not? That x squared? No, never mind.
All right, let's look at one more example. Well, actually, maybe a couple more. But wait, I need to look at my schedule. 250. Okay, we're doing okay. Do we need to go back? Did someone say wait? Okay.
And these are always available online.
4x squared plus 16 equals 16. So we don't have a b here. We don't have the bx part. So we can solve by taking square roots. I'm going to start by subtracting 16 from both sides. And I get 4x squared equals 0. Divide by 4. I get x squared equals 0. I take the square root of both sides. Want that in blue, there we go. Square root, and I get x equals, the square root of 0 is 0. I could write plus or minus 0, but plus 0 and minus 0 are just 0. So here we get one solution. X equals 0 is the solution to this thing. Yes?
When there's two solutions, is that like -3 and +3? Or like, I'm confused how you know if it's like two wrong solutions. Like, we know that this is one solution, but
So whenever you take a square root and you get a number, it will always be two solutions.
okay, gotcha.
So whatever the number is that you take the square root of the thing and you get 7.3, your answer would be plus and minus 7.3.
Okay, great.
And that's because our graph is the same on one side of the axis of symmetry as the other. So whatever number is over here, it's the same over here on the negative side. All right, last example. 3x squared plus 15 equals 0. There's our quadratic equation. Subtract 15 from both sides. I want to get the x squared by itself. So I have 3x squared equals negative 15. Oh, I heard somebody say what's going to happen here. Somebody saw it already. X squared equals negative 5. I take the square root of both sides. And I'm trying to take the square root now of a negative number. If you plug this in, your calculator would give you an error. So this would be no solution. Later we'll talk about, do we talk about that in Algebra 1? About the complex roots?
No.
No? Okay. In Algebra 2, you'll talk about that. What happens when you take the square root of a negative, and you can do some more stuff with that. For now, for what we're going to do, it's just going to be no solution.
No solution for Algebra 1.
And your book will probably say no real solution, because there's another kind of solution.
We're okay with no solution.
Right, no solution is fine. And this would be a case where this graph would never cross the x-axis. That would be like this other graph that we did. This one would have no solution. And the graph of this other parabola that we just did would never cross the x-axis. That's what this means when we get no solution. For this parabola, the vertex would be at x equals 0. And that would be the only place that the parabola touched the x-axis. So if you have a choice, if the problem just says solve this quadratic equation and it looks like this, I would choose, personally, I would choose to solve by taking square roots rather than solve by graphing.
Square roots are your friends. That's
Yes.
like your new best friend in math.
Yes. And I know we all have a lot of best friends already in math, but there's always room for another math best friend, I think.
This is a good one, though. It's a fun one.
All right, so questions? Okay. Let me get to our, I forgot, I had someone in the room, so I couldn't write up on the board. All the science classes have to come into the C-wing. Page 564. Number 8 through 36 even. And then numbers 35 and 51. Okay, there's that.